Hi, in this video I would like to show you how to start working with BigClown home automation systems. This is an open source modular system which you can build yourself, no soldering needed. It's open source, it's low power, and it's can be used in many different ways. You can control or monitor temperatures or values on your phone over the internet, or you don't and you just use your Raspberry Pi and have this system closed in your network. It's really versatile. Also, it's possible to log measured data, for example, like to the professional open source software Grafana. And so there's many use cases. Today I will like to show you just the basic usage, which means I will have this button, this wireless button, and control let's say the LED strip over the Raspberry Pi. So you will need only Raspberry Pi, which will be running all the software. So let's start. The BigClown consists also of many other modules. There's like 20 modules, output, input modules, relays, sensors board, low power sharp memory LCDs, different battery modules. This one is big. In the button module there's one smaller battery module, and also there are these tags which have one sensor on it. This is the temperature and this is the humidity. So it look like this. No luck today with focus. And also it's possible to use the Sigfox module. All this comes with a powerful SDK, multi-platform development, libraries and build system, and it's really easy to start. And you, in basic with basic kits, you don't even need to program, to write your own program or compile. It's already prepared for you, as you will see later. And this is the rotary encoder module. All right. So as I said, you start with Raspberry Pi. The Raspberry Pi 3 and 2 is supported. So you take your SD card out, put it into your computer, and you can use the original Raspbian, or you can download specialized, customized Raspbian from us. So you have really the easiest start. So you go to bigclown.com here. Then support, GitHub. And you use the BC Raspbian. You download the latest release, which is 1.5.0. And I've already done that. After the downloading, you unzip this archive, and you can flash the image the usual way, like use the Win32 disk imager. Then after flashing, you put the card here back to your Raspberry Pi and power it on. So let's do that. You need just Ethernet, your network, and the power. LED is blinking. Okay, if you take a look on the documentation, which is also in support documentation on Learn, you can see, you cannot see the quick tutorial, which is basically what I will do today, something similar. So you install the Raspberry Pi, and here's then after the Raspberry Pi has booted, you use hub.local address to connect to the Raspberry Pi. Because I have Windows 7, it doesn't allow this naming yet. So you can take, if it's also your case, you need to take a look on your router or to your phone and scan the network for the Raspberry Pi. So I can connect to the Raspberry Pi like that. And in the start, there are some flows. This is the node red. You use, sorry, you have to use port 1880. So remember, yeah, hub.local or your IP address and then 8080. And there's a running node red, which will be used to set some rules how the network and the values will be controlled and showed to you. All right. So now I have booted the Raspberry Pi. I also need to connect over SSH to it, so I can use PuTTY and connect to it. The login credentials are the default, so Pi and password is Raspberry. All right, I'm in. And if you use the prepared BC, BigClown Raspbian, there are also some useful tools like BCF, which we'll be using today. And the first thing we need to make sure that we use the latest firmware in our devices. So you can you connect your dongle, which is a gateway for the 868 megahertz network. So I connect the dongle in. All right, and it has started, but I need to flash the latest firmware. So there's a gateway firmware running in the background. I can show you by PM Service Manager. Okay, so it's running, and first then I will flash the latest firmware to here. So I use the BCF update, BigClown firmware update, and this command will update, will download all the binaries from GitHub. So now it's actual. So I use BCF list to show all possible firmwares. And I need to update the gateway. So I will use this firmware. I can also use the core module as a gateway, but it's a little bit big module and it's better to use the cheaper one and smaller one, the gateway. So this is the firmware I will use. And then, so BCF flash device is the TI USB 0 and then the latest firmware. Okay, yes, I need to stop the service first because it's using the same serial port. So PM2 stop BCG UD. UD means USB dongle. Right, it's stopped, so try again. And because it was already downloaded, it just rewrites it again. And verifying. Okay, we have it running. So I can start my service. Okay, it's running. And then I can switch to the Node-RED and take a look at the debug. Where I do this, I will disconnect the dongle. You see MQTT message which has now dongles connected. This is because we are subscribed to the hash topic which shows all MQTT messages which are running on the Raspberry Pi, and this will debug them. So I'll reconnect the dongle, and I can see that I have a dongle with the latest version connected to it. And I don't have any nodes paired with this gateway. So now I will pair it with this. This will be a button kit. This is really nicely engineered box which slides like that. And here you can see what this module consists of. It consists of the core module, the battery module mini, and the button module, which is big fat button. There's also button on the core module, but this one is certainly better. So I will flash the latest firmware to this remote node. So I will disconnect the dongle for a while, just to make things simpler. Connect it, and now this first version core modules needs to be restarted in a special way. So I will hold the B button and short press the reset, and now it's in a flashing mode. The newer one, the core modules 2, don't need to do it like that. It will be, you will flash them the same way like with the gateway. Sorry, like the USB dongle. Okay, so this is connected, so we can flash the latest firmware. Again, let's take a look what firmware do we have. And there's one good comment, BCF search. If you have lots of firmware, and you can see we have this is the firmware we would like to use. So BCF flash, and as I said, this is the core module 1, so we need to use the DFU flashing, but in a version 2 you use just the device and the serial line, and it will be flashed. And then I put the firmware here. Also the DFU on this module is not as fast as on the core module 2, which will have faster upload. All right, so it's done. You can't see, but the light was turned on. Okay, so I can disconnect it. The great thing about these low power modules is that they will select the best power, the best voltage. So if I connect it over USB, then the batteries will be disconnected, and now it's running from the batteries. So I do another reset. Yeah, and it's turned on. All right, so I reconnect the dongle. You will see that there will be MQTT message. All right, and then I can pair this module with a gateway, and this will be done in a graphical interface. You can also do it in here by Mosquito publish, but this is prepared, and this is much simpler. So here are two options. If you use USB dongle, you use these buttons, and if you use a core module as a gateway, you use these buttons. It's a little bit complicated, but we were thinking that somebody would like to reuse these original core modules as a gateway, so why not? So I will press the pairing mode start, and the pairing LED will start to blink in here, right? And then to pair this together, I just need to press reset or take away batteries and put them back. here you can see that I have started the pairing mode, and in a moment when I reset this port, it will write information like firmware and address of this node. So I will press reset, and it's paired. So it's a push button kit firmware in this node. And now if I press the button, then you can see I have the messages in MQTT. So now I will stop pairing mode because I don't want to pair more modules. Stop. All right. And I can put it back to the enclosure. It slides like that with a USB. These enclosures are also open source. You can download them and print yourself. And here are here are the O-rings. So the both parts will hold together. Also, there are holes, so you can fix this to the wall in case you use, for example, motion sensor in here. Right? Just to check it that it works. Yeah, it's working. We have 9/10 press of this button. So this is the beginning. This firmware also sends the temperature, because every core module has its own accelerometer and temperature sensor. So if I warm this somehow, you can see that temperature changed. And by this, so we can start to make some flows in here to create some rules or to visualize the data. So the easiest thing will be to show the temperature. So I use MQTT input. I can copy this topic, and if you need more information where you find these topics, it's in the integration and MQTT topics, and here you see all topics which modules are sending, and down here are the topics for gateway to start pairing, stop pairing, and delete or paired modules. So temperature is this command, note, then the name, then thermometer. This is the I²2 bus number, and this is the temperature address. And so you can have much more temperature sensors, I²C. So let's try this. So I've copied this value, note, push button, and temperature. All right. If I will pair more kit push buttons, this number will change to 1, 2, and so on. All right. And then we need to visualize this. So since we have also pre-installed dashboard in BigClown Raspbian, we can put a simple gauge here. And by double-clicking, you create the new tab, new tab and new group, and we write that we would like to have different range, so from 10 to 30 Celsius. Sorry, and it should work. If not, we will learn. Okay, deployed. And it's 10 degrees because it doesn't change yet. And it's here. All right. So this is a really simple way how to start with the BigClown. I can also give a graph or chart if you would like, just by connecting it again. Sorry, you don't see this chart. All right, done, deploy. And you can see the chart here, and if the value changes, it will redraw the graph in time. There's many other modules like this. This is the climate module, which has optical sensor here, barometer, humidity sensor, and also the temperature sensor. up here. So you can monitor much more variables than just the temperature, because the button kit is basically just for pressing the button. And speaking of button, I try also to give you use the buttons. So I take a look to the documentation, to the topic, button event count. So I will copy this, go back to here, push button, and there will be the different topic. And then I can put, for example, I don't know, text here, home text, right, deploy. And then here's the text, and when I press the button, it should increment. Yes, it does. All right, now let's have some more fun and control this LED strip. So this will be done. First, we will flash another core module, or maybe not. This one is already pre-programmed, so it works the same way like the flashing, like with this battery. Sorry, with this button kit module. So I will just power up this, and this is pre-flashed with a different firmware, because it's not this has LED strip, so this has to be powered by this power adapter, which comes with this kit. And the firmware which is in this module is BCF search, and this is power module, this blue board. So I will search for power, and you can, yeah, this is flashed with generic node power module with RGBW, which means this digital LED strip has four colors: red, green, blue, and white, and it has 144 LEDs. So this is the right firmware for this module. So you just copy that, write BCF flash DFU or / device in a core module 2 and flash the firmware. So I will power up this module right now. All right, it's already working. One nice thing about the generic firmware is that it supports all the modules and all the sensors and all the relays and the display even. So I will just show you that if I put a LCD module on top of it and power it on, that you see that I have 22.9 degree. And if I use, for example, this is a temperature tag, and this is the humidity tag, which can be connected here, that I'm also immediately measuring humidity. And when I pair this module with the dongle, it will automatically send all the values, all the sensors to the MQTT. So there's really no need to program this, but it's all on our GitHub, so you can change it very easily. But it will be covered in new videos. Another thing about this display is it has 2 buttons, so I can cycle. I can cycle through many other pages. And here's the interesting part, which is LED test. So even if you just take this out of the box, you can test it without any connection and any programming. So the testing looks like this. It will test all the colors: the green, the red, blue, and the white color, the 4th channel separately. There's also other effects, but it can be controlled also by radio, which we can try to do. So now let's pair this module. So again, we need to start the pairing, which is here. The LED here will start to blink. And I just reset this. Sorry, I switched to the debug tab so you can see the pairing. All right, and we have a new node with a generic node power module, and it already is sending the temperature and the humidity, as you can see. So I can take this topic and create another graph or another value. It's really simple. So this topic, and I would like to show some this gauge. This will be remote humidity system. Deploy, and it's here. So I need to change the humidity. It's sending every few 10 seconds, but if it changes G's quickly, it will send the value immediately. And I don't like range, so from 0 to 100%. Deploy, and it works. If I press this, going up. Right, the same works for the temperature. So now I have paired this generic node. I will stop the pairing to stop blinking light here. And as I said, I can also control this LED strip. On the power module, there's also a power relay. So we can start by, for example, by pressing this button, we would like to turn on and off this relay. So let's start working on that. Also, you can have many other flows. This is disabled flow, which has some cheats for me. But let's start from the beginning. So we will use the event count from the button kit, and then we need to write an MQTT. And again, I will switch to the MQTT topics documentation, and I will search for relay. And we have two relays, one on the power module and second to the relay module. So we have power module, so this is the topic we are interested in. All right. Note. Every time I make sure that you don't have any trailing spaces, because it really doesn't work then. So this will be the generic node 0, and should be all. Then we just need to pass true or false here. So I can, just for a debugging purpose, I can prepare two buttons with a boolean. One will be true, and second with a false boolean. False. And by connecting them and deploying, I should control the relay. Sorry, false. Yeah, that's also true. Now it will turn off. Okay. So now I just need to connect this together, but we need to change what is flowing through, because this block is accepting true or false. However, this block is sending the number of button presses. So we need to add a simple function, but it's really simple. We just use modulo command, so message payload, then message payload modulo 2, true, false. So we are changing the payload from the number which we are dividing by 2 and getting the modulo, and then we send true or false back to the payload and return the payload. So this is our modulo block. And we can also connect it together like that. And if everything is working, it should be clicking. All right. No, now it's false. Okay, now it's true. Okay, so it's working. And another thing we would like to do is, for example, control the color of the LED strip. So let's go back to the documentation. And go to the LED. This is the LED strip on the power module. So we can change the brightness of the current color. We can set the current color by sending the hexadecimal notation, or if I use, in this case of LED strip with a white color, I can send the white color in here. Or I can say that I would like to turn on 20 LEDs with this color and 20 LEDs with that color. Or I can start the test exactly the same like I was starting it with this button, you know, that circling colors, and I can do it again here. There are many other effects, but it's explained. It's not in the documentation. It's on the GitHub of this project. So what I think we can try is to turn on the whole LED strip with a single color. So this will be done with this topic. And we will use the color picker. And again, this will be the generic node 0 color set. And again, there's a small issue that the color picker is giving the color without the hash symbol in the front, and also that we need the MQTT needs the JSON representation, so we need to do two things in a simple function. JSONize. So as I said, we need to make a JSON. So I just add another pair of these symbols. And also we need to add a hash symbol in front of it. So we can also add the debug output just to show you how you can use the debug blocks. Okay, I forgot something. I need to open this, and then I can close it because it needs signing to the group, but it already does it. And one good thing is send values during editing, so it will send data immediately and not just after I click on sending. This could work. All right, please send. Oh, this is the color, and it's working. Perfect. So I will dim it a little bit down so you can see the color. So red, blue, and green. Perfect. I think it's working fine. And our LED, sorry, our relay is still working. All right. I've showed you already a lot of usages for this, but I would like to show you one more thing, which is use your mobile phone to control the color. So this will be a little extra, and I don't have oh, okay, I will show it on this camera like that. We'll see. There's many MQTT applications for smartphone. For Android, I use MQTT. Sorry, I think I will switch it like that. And all you need in your MQTT application is add another MQTT broker and write the IP address of your Raspberry Pi. So pi.6 and IP address 92.6, and all other values are the default. Save it, and I try to connect, and it's connecting. It should be the firewall in Raspberry Pi. It's enabled, or sorry, is disabled by default for MQTT broker. No, so what I did wrong? I'm on the network. Oh, stupid mistake. You saw that. 192. Again. Connected. Perfect. There's nothing to see here because we haven't added anything. So I will add, for example, color chooser. Then I need to add a topic. Right now I will create my new own mobile topic. So I will write just mobile / let's say RGB. Right? And this is the topic we will be publishing. So I save this. And when I press any color, it will change. It will be outputted in our debug output. Press OK, and you can see mobile / RGB. And Node-RED knows this is a color, so it will show its representation. So now I will just take this, and again I need to put it this topic. So I select input MQTT topic, use the mobile RGB. Then because this color chooser on the application is sending hash and a number, so I don't need add another hash. So I need, if I do this, this JSON will add another hash because of this. So I need to copy this and create the apostrophes, but without the hash symbol. So it should be working like that. This can go away. Deploy. So let's see. Choose the LED once again, and it's working fine. Then here you can see that there is a color which comes from the phone, and there's a color which has another pair of apostrophes, and it's going to the generic node color set. Fine. All right, maybe I can try the latest command, which is this compound set. Why not? Let's try that just by adding the button. So I will just inject topic. The top topic is clean. No. So I will do this like that. Copy the topic. Put it here. Sorry. Generic node LED strip compound set. All right. Connect it, and I will inject the example from here, which is 20 LEDs red and 20 LEDs green. Inject, I can use JSON or string, it doesn't matter, I hope. And let's see, this is the beginning of the LED strip. So you can see how many pixels will have which color. Inject. All right. 20 LEDs red, 20 LEDs green. These are really bright, so I will try to lower it down a little bit. Perfect. And the white color stayed the same. Oh, it's all, well, it's already white. Again. Right. Red and green. Maybe I was moving this and it reset it. I don't know what would have happened that it was all white. So this is pretty much how you get started with BigClown. As I said, there's a lot of other modules. You can stack them on the core module. You can use this lux meter, which is really fun to play. Also, there's a peer module which senses movement. I don't have it with me right now. So let's take a look at the BigClown webpage. There's also one thing that they are starting Indiegogo this month, so you can order the modules and the kits much cheaper. I will show you simple. I love these animations. This is the motion sensor and the covers. So there's also a cover for the dongle. Right, and this is all you can build. If you take a look on the GitHub, then you see Raspbian and the BCF means that it's BigClown firmware, so you can see how many projects we have right now. The all projects are documented. There will be much more projects in the future, and we have also tutorials how to program your own firmware, how to run MQTT broker on your computer, and use the Grafana, and also the Blink application. It's also possible to control this from the outside, from the internet. It's up to you how you decide to use this kit. So it's not necessary to have this opened to the internet. So you're safe and there are no issues with hacking. This is also a nice module. It's a system on modules which you can reuse in your own projects, add your own relays, inputs, and use the small cheap module which is already pre-soldered. And it has also the temperature sensor, and this is the crypto module for radio communication to be secure. All right, I hope that this was interesting to you. And I hope if you have any more questions, just write it down below. Every links will be also in the description under the video. And if you have any idea what you would like to do with this kit, with this open source modules, let us know. Bye for now.